white powder, MSG.
Smothering this with that sauce is really just worth the time you put into it. It's so rich and creamy, it goes great with a steak like this.
Hello guys, welcome to the Mind of Food, where love of food meets the love of learning. I'm your host, ATY. In my first video, I'm going to talk about the underdog of flavor, umami. The history, the science behind it, and some interesting facts towards the end. You might be wondering, what is umami? Well, you've probably heard the term before, but umami is basically the fifth flavor. People would describe it as a meaty, savory, or brothy taste, and it coats your tongue and makes your mouth water. Now, why should you care about umami? Well, if you think about it, umami is actually in a lot of food you eat. Every time you're cooking and you reach for soy sauce, fish sauce, or miso, what you're doing is enhancing the umami or savory taste of the food. The umami flavor is also in condiments used like ketchup, food products like KFC chicken, or a bag of potato chips. This video will therefore help you identify the different sources of umami so you can use them when cooking in the kitchen. It'll also help you identify some of the umami products that are used in your favorite foods. You might cook a dish and it's salty enough, but it feels like something else is missing, and that might actually be umami. The last reason is that you can flex your knowledge to your friends. If your friend is like, what is MSG? Or you're in a restaurant and you're describing the taste of food, like soup, as umami, it makes you sound smart. Now, we said umami is found in sauces, right? But where else is umami found? It's found in a lot of products like aged cheese, Italian tomato sauces, cured meats, mushrooms. Basically, umami is ubiquitous. Well, since umami is found everywhere, you'd think we would have known about this flavor since ancient times. But that's not the case. Umami was first discovered in 1908 by Japanese scientist Dr. Kikune Aikida. Dr. Aikida found that a dish called dashi, which is made out of seaweed and fish flakes, had a flavor distinct from the other four flavors, which are sweet, sour, salty, and bitter. In a paper published later, he coined the term umami, which basically translates to the essence of deliciousness in Japanese. After doing a lot of experiments on dashi, he found that the compound responsible for the umami taste was glutamate. Years later, they discovered a number of other umami compounds, namely 5'-inosinate and 5'-guanylate. Don't worry about the compounds right now, we'll talk about them later. And just to continue, it was not until 2002 that the taste receptors for this flavor were identified. And after they were identified, then it was proven that umami was a basic flavor. When I personally think of umami, I think of mushrooms on Meat Lover's pizza. Honestly, if you don't like mushrooms on pizza, you need help. Anyway, let's talk about the science behind umami. Just like we discussed, there are three umami substances: glutamate, 5'-inosinate, and 5'-guanylate. Now let's talk about them in turn. So glutamate is a non-essential amino acid, and it's used to make proteins, basically. It's also used as a neurotransmitter in the brain, which just means it allows your brain cells to communicate with each other. While 5'-inosinate and 5'-guanylate are nucleotides, so they're kind of like the building blocks of DNA. Now let's talk about the additives in food that give that umami flavor. MSG is usually considered the purest form of umami, so it's kind of like how table sugar is the purest form of sweet. Now, Uncle Roger's favorite substance is basically formed when glutamate, which we've talked about, is reacted with sodium hydroxide to form monosodium glutamate, hence MSG. Now, MSG is found in a lot of products like potato chips, Asian dishes like fried rice, KFC, and others. The other additive is a product of 5' guanylate, and usually 5' guanylate is extracted from seaweed, and it's added to food as disodium guanylate. Disodium guanylate is also known as the food additive E627. So whenever you see E627 as an additive on your potato chips, you know it's disodium guanylate. So the other one is 5' inosinate, which is added to food as disodium inosinate, as the food additive E631. Now 5' inosinate is found in animal products like chicken, meat, like beef. Now if you notice, the products I've mentioned all have one thing in common, and besides them being like umami, they also have salt. So salt actually enhances the umami flavor. This is because the receptors that respond to umami also respond to sodium, and sodium obviously is the essential component of salt that makes it salty. As I was doing research for this video, I was wondering, if salt enhances the umami flavor, what else can enhance it? What if I combine these three compounds into one dish? Would it give me an umami explosion? Well, fortunately the answer is yes. For example, the umami flavor of a mixture of glutamate and 5' inosinate is 8 times greater than that of glutamate alone. We usually combine substances containing these two compounds. For example, ingredients like tomatoes, garlic, soy sauce, and cheese, which contain high glutamate, are combined with chicken and beef, which contain 5' inosinate. Okay, now that we've discussed the more general stuff, let's go into the science of how these substances work. So just like there are 3 umami substances, there are 3 umami receptors. This includes T1R1 plus T1R3, mGlu-R4, and mGlu-R1. Don't worry about what those mean. But what you have to know for this video is the major umami taste occurs through the T1R1 plus T1R3 receptor complex. Now these two receptors act together, so when one is stimulated, the other one is stimulated. Now for the science behind how these umami substances have synergy. Now when glutamate binds to the T1R1 receptor, it activates. Now 5-inosinate can bind to a nearby site called the allosteric site, which further activates the receptor. So these substances work in synergy with each other, which means they just work together. So it's kind of like having your car break down and you start pushing it to get it to start up again, and someone is walking by the side of the road and they come up to help you push the car, and your car will start up faster that way, and that's kind of like how this works. So what does activation of this receptor lead to? Activation of this receptor would lead to the signal being transmitted to your brain. Now the exact mechanism of how that happens is beyond this video. Okay, so we now know that there are specific receptors for the umami taste, and that umami is found universally in foods. But why do we have these umami receptors? Well, it is not clear from my research why we have these receptors. One interesting thing I found is that mother's milk contains a high level of glutamate, similar to the level in dashi that we mentioned earlier. It also contains 5-inosinate. So it seems like even from a young age we are primed to recognize umami. Well, I'm not really sure about those who aren't in the breastfed club though. What's even crazier is that human amniotic fluid, which is basically the fluid that babies float in the womb, contains significant levels of glutamate. So we basically bathe in umami in the womb. I'll leave you to think about that. One reason we might have developed this ability is because glutamate is a signal for protein intake. Kind of like how sweet is a signal of carbohydrates, then they should be a response to it like sugar. When we consume sugar, our brains already interpret that so that even artificial sugars elicit at least a small insulin response. In the case of glutamate, what I found is that glutamate might just be another signal our body has to confirm that we've had enough nutrients. We talked about T1R receptors and how they're mainly responsible for the umami taste. Some people have mutated TL1 receptors, so they cannot taste MSG as well as other people. Okay, finally, I want to touch on the health implications of umami substances. Now, before it was thought that MSG was a health hazard, but that's long been debunked. MSG actually makes a great salt alternative because less salt is required to give a great taste, because not only are you getting that salty taste, you're getting the umami, so you get a more intense flavor than just adding salt, so less salt is required. And this may be useful in helping reduce the risk of cardiovascular disease like stroke and heart disease. We also talked about how it increases satiety when combined with proteins, so it helps you stay fuller for longer. Whether this actually makes a difference in things like obesity is still to be seen. So there we have it. I hope this video was somewhat informative, so next time you see that white powder in the store, don't be afraid to take it. So this has been The Mind of Food. Like and subscribe for more food science videos. Thank you.